Let's look at another problem. So the graph of the first derivative f prime of x of a polynomial function f of x is pictured at the right. Use the graph to answer questions 8 through 11. What type of polynomial function is f of x? Give a reason for your answer. Well, if we look here, and notice it says that it's a polynomial function. Right? So f prime of x is a cubic function. And when we have polynomial functions, right, we can use the power rule. So the power rule can be used to differentiate polynomial functions. And when we use the power rule, the power decreases by 1. Right, so therefore, since f prime of x is cubic, right, then f of x has to be degree 3 plus 1 or quartic. All right, so when you take the derivative, your power goes down by 1. Right? So if the derivative is cubic, then the original function f of x has to be quartic. Right? So at what values of x does the graph of f of x have a horizontal tangent? Right? So remember that the graph of the derivative is just the slopes of the tangent lines. So if we look, we have 3 places where f prime of x equals 0. So everywhere f prime of x equals 0, f of x is going to have a horizontal tangent. So f of x has a horizontal tangent. Now we're not saying yet that it's a relative max or a relative min, right? Could be. We have to look at our value or what's happening to the derivative a little more closely, but f of x definitely has a horizontal tangent at x equals -2, x equals 1, and x equals 3, because f prime of x equals 0 at these values. Right? And we know that this means the slope of the tangent line is 0. On what intervals of x would the graph of f of x be increasing? Right, so remember, these are slopes. So everywhere that the graph of the derivative is above the x-axis, f of x is increasing when f prime of x is greater than 0. Right? So that's our little reminder there. So on what intervals of x would the graph of f of x be increasing? F of x is increasing on -2 to 1, and then again from 3 to infinity. And we know this because f prime of x is greater than 0. In other words, it's above, the y values are above the x-axis. On what interval of x would the graph of f of x be decreasing? All right, so now if we look, I'm going to write in purple. No, yeah, purple I guess was okay. So here we see that the y values are negative, and f of x is decreasing when f prime of x is less than 0. So f of x is decreasing on negative infinity to negative 2 and 1 to 3 because f prime of x is less than 0. So in other words, the y values are below the x-axis. And I should actually add on this interval, or on these intervals. Let me add the same thing to the one above it, so it's just really clear that the intervals we're giving is where the function is increasing or decreasing, respectively. And that's the last question we're going to answer on this graph. All right, in the next video, we'll look at a new problem. Bye for now.